Well, good afternoon, everybody. My name is Troy Raska, and I'm the Vice President of Marketing and Communications for Pure Air Control Services Incorporated. And I'd like to welcome you today to our online workshop series, Meeting and Exceeding ASHRAE COVID-19 Guidance. With me today, I have Carl Stefan. He is our Northeast Regional Manager, a certified indoor environmental consultant, and an industrial hygienist here with Pure Air Control Services. Welcome, Carl.
Thank you, Troy. Hey, everyone.
Excellent. So today we are going to be covering the guidance for reopening buildings as issued by ASHRAE. And so I wanted to take just a second to give you guys a little bit of background information about this webinar and sort of our perspective on this guidance. So first of all, again, thank you for all who signed up and who are attending this webinar. We realize that we have a very diverse group of people here on this online workshop. And so we have everybody from facility management to procurement to engineering to HVAC tech and partner contractors. So welcome one and all. I want to start off by saying first, Pure Air Control Services is a longtime member of ASHRAE. So we support this organization. We adhere to their guidance and guidelines when we are conducting our environmental investigations and cleaning of these HVAC systems. And as such, today's workshop, we're speaking on our own behalf as Pure Air Control Services. So again, we're thankful for the guidance that ASHRAE gives us. And so I just want to kind of take a second to mention that. So, you know, we're all in the middle of this pandemic. We sort of know where it started. We're actually almost plus 1 year now. And very early on, ASHRAE began to mobilize and put this guidance together based on the unfolding pandemic conditions that were happening in real time. And so, you know, as I recall, it was probably about July or August that they really updated their website and put together a very robust set of documentation to help building owners and mechanical contractors and engineers be able to start to consider how this pandemic was affecting buildings and then what you wanted to do about it, whether you had people in your building or you were closed and under lockdown conditions. So as this is developing, so has this documentation. ASHRAE has been very good about making revisions and updating this website. So as we move through this presentation, you know, we're always going to recommend that you refer to their full guidance on any one of these topics, and that the recommendations presented here are just, you know, general recommendations, again, based on this one executive summary, which was a very good overview of these 8 pillars of strategies to think about. And again, that's the Guidance for Reopening Buildings PDF that ASHRAE put out, and I believe was revised in December of 2020. And then, of course, we're going to give you some recommendations of how Pure Air Control Services, services and products fit into this guidance, and in some cases go above and beyond it to create engineered solutions for your situation. So these are additional tools that you could put in your toolkit, if you will, by partnering with us. So again, as I said, we're going to look at that particular document and their 8 pillars, which are these main topics: building readiness, modes of operation, systems evaluation, inspection and maintenance, of course, your ventilation and filtration, which has been a big focus here, pre and post occupancy flushing, water systems, and then energy savings. So, you know, as we all know, and we're living through this for our own businesses, institutions, and helping our customers with it, you know, it all starts with having a building readiness plan. ASHRAE recommends this. We've recommended this for years, having a preventative maintenance plan in place, knowing what it takes should different situations come up. And so, you know, very briefly, ASHRAE's building readiness plan includes these main areas of focus. What is the intended operation? of the building, and then what are your temporary and permanent mitigation strategies, right? And these are non-HVAC related, so in the occupiable space and from a normal buildings operation standpoint, and then specifically about how the HVAC system is functioning. And of course, again, that includes increased and improved ventilation and air cleaning technologies as referenced by ASHRAE themselves. Now we know that there are many different types of buildings that have many different types of uses, right? So when we look at the modes of building operation, today we're talking at a very general level about best practices for any building. But ASHRAE themselves, if you go to their website, has actually revised this documentation to very specifically include different types of buildings. So again, we refer you back to there if you're operating a school versus a hospital versus an office building or a manufacturing plant. Again, check with ASHRAE because they're going to have the most up-to-date information specific to those kinds of buildings. So when we talk about this plan and this executive summary today as issued by ASHRAE, they're talking about their mode of operation that they call epidemic conditions in place, or ECIP. And so when we're looking at a reopening guidance or a guidance to operate in your building while the pandemic is still going on, this is the mode of operation we're talking about. And that is operating in this ASHRAE occupied mode when people are present in the building. And that includes even lower capacity occupancy, where social distancing is happening, or they're revolving a workforce in and out of the office building or even a school, right? And so the guidance documentation that we're referencing here, or where you want to learn more about the modes of building operation, is the ASHRAE Building Readiness PDF in the chapter that's called Reopening During Epidemic Conditions in Place. And so what does this all mean? Having a plan, understanding the mode that you're operating in. Well, first of all, ASHRAE recommends that you evaluate all of your systems. And I think this is really Carl's area of expertise, so he can sort of touch on this and ASHRAE 11/2018 to help us understand what this means.
Sure, thanks, Troy. And just again, a reminder, as Troy mentioned earlier, keep a tab and check on ASHRAE and their updates and what might be more specific to your facility, your use facility. As this isn't inclusive of all the details, but it's going to be a good general overview to get you started or along the way. And when it comes to systems evaluation, I like how ASHRAE coins it. They say tactical commissioning, right? So what we're doing here essentially is we're looking at documentation and we're looking at inspection of our systems and our components. What does that mean, right? So for the documentation, we're looking at things from a recent test and balance report, a recent commissioning, maintenance logs, your BAS system, its sequence of operations, these little areas that may have gotten overlooked or may have been a while since they've been performed. And then we take it into the inspection component, or the inspection of systems and components, right? So not just a boiler, a chiller, an air handler and VAVs, but the actual system itself, the chilled water system, the hot water system, the air handling system. Now starting to consider the components and the system and how they all interrelate. What status are they in? Where are the BAS set points as another example? But we're taking this as far, ASHRAE even goes as far as things like integrated system, a lighting control. So there's a lot to it, but again, it's the idea of revisiting where you are and what's there in paperwork, what's been documented, and where, revisiting where we need to go from there, and how to address and start to get into actually inspecting those different components to see where you fall. And on this slide specifically, there's a couple other notable points. Some of the big things you're hearing and seeing is outside air ventilation, right? That's something that's very prominent right now. Making sure that that is within design requirements. When's the last time it's been tested? What is the kind of the physical condition of your outside air system, the dampers, for instance? Looking at something as simple as what MERV filters, right? That's another very hot topic right now, which we'll get into, which is filtration coming through your central system. So, one item that comes up with this is ASHRAE 11-2018, or field testing of HVAC components. And what this is a procedure for specific devices that control operation of the HVAC system. It's performed basically to ensure efficiency and functionality. And we look at each of these devices and the basic function that they're intended to perform under a set of conditions, right, based on design. When this building was constructed or renovated, when these systems were put in, they were designed to operate at a certain capacity, a certain functionality. And we need to verify and revisit to better understand their performance. So there's different levels of that as well, right? So we have ASHRAE saying, okay, let's check our documentation, let's start to do inspections. You want to start off with a simple approach, but be aware that you may and can get very in depth to actually learn more about the functionality and make the corrections now to prosper you, as you move forward in the reoccupancy or during occupancy in the future of coronavirus. And just to touch upon that, we have with 11-2018, not just again some of the verification, but actually output testing and performance testing. So some of you may be pretty familiar with the performance testing side right now, looking at how your HVAC systems are functioning for outside air delivery, overall airflow, and air changes in the various spaces.
No, that's exactly right. And so when we're talking about evaluating the system, obviously we're looking at it from a performance standpoint, mechanically, and from an engineered standpoint. But then again, what about the actual hygienic conditions or cleanliness of these units? And then how is that cleanliness affecting the engineered performance of the system? And so that not only includes, microbial stuff, but the amount of fouling, maybe the amount of degradation in older systems, right? And so that's where someone like Carl comes in on Pure Air Control Services behalf, and our other technicians in our Building Sciences division, in that we can come in and inspect these units with what we call our HVAC Hygiene Assessment program. And so this program will, certainly look at how the system is performing mechanically, but it will also look at the visual conditions of the equipment. We will be able to pull environmental samples from the inside of the AHU, the supply, the return plenums, and the associated equipment, and be able to look at that under the microscope and from a laboratory perspective. To look at any kind of microbials, particles, allergens that might be built up in that system. And then, of course, we can use this kind of, or rather you can use this kind of assessment to create a detailed mechanical inventory. We know a lot of our customers that we've dealt with in the past, we go in to maybe spec some work or whatever, and a lot of folks really don't even have a detailed mechanical inventory. So what we've found is schools and healthcare provider systems love to have this kind of assessment done as a programmatic supplement to their maintenance planning, campus-wide, right across a portfolio of buildings, because it gives almost instant insight into the conditions of all of these assets. And then, of course, once you have all of that information and that it's inventoried and in a database, now you can start to prioritize the maintenance of these systems. So this hygiene assessment will look at these conditions, performance, hygiene or cleanliness, and then it'll grade these systems, red, yellow, and green, for what are the most critical systems that are in need of attention, what are going to need to be sort of cleaned up, and then what are the units that are actually in good operating condition. And so that'll really help prioritize and fit into this building readiness plan as you're looking for deficiencies to correct. Did I miss anything there, Carl?
I think you nailed most of the main points there. I think what I comment on is just that we're looking at functionality of units as a big item right now, but we have to remember the hygienic condition, it plays a very equal and critical role. Even if we're making improvements to outside air percentage or flow and making sure our systems are test and balanced, if there's still a degree of fouling, if there's still microbial such as bacteria, molds, those are in themselves allergens, indoor air quality issues that are waiting to happen. So we need to kind of hit this from both ends, and that's one of the goals of the HVAC hygiene assessment, is to look at the physical performance, but also the environment, the actual biological environment within these units, and help kind of take a holistic approach to making the corrections.
No, that's absolutely right. And of course, we understand that many of you on this workshop today are already doing a lot of this for yourself, or you might partner with a mechanical engineering firm or mechanical contractor. And I'm here to tell you that we've partnered with many different institutions, organizations, other contractors to supplement programs that you already have in place, and maybe fill in the blank on a certain area of expertise that they're not able to provide. Again, such as the environmental testing of these systems. Then next, after we look at the overall systems evaluation, ASHRAE goes further to talk about actual inspection and then maintenance, or the kind of corrective action that you can take once you have everything else documented and you're ready to set off on this plan. So again, these are some pretty thorough standards here, Carl, that ASHRAE is recommending.
Yeah, absolutely. But I mean, again, going back to our previous comments and slides, it's these systems are complex and there's a lot to it. ASHRAE 180/2018, it's really focusing on how to make the system achieve the acceptable thermal comfort, the energy efficiency standpoint, but also the indoor air quality. So there's a lot to it. And with the HVAC hygiene assessment, one of our more specialized areas is the environment in there, the hygienic condition. But Troy, as you mentioned, this is where a lot of building owners are already working with engineers. They're HVAC mechanical, but we also partner and work with a lot of HVAC mechanical and engineers, because these various components are specialized, and it's a great idea to bring in multiple contractors from different specialties, different backgrounds, to do exactly what ASHRAE 180/2018 is focusing on. Not just energy efficiency, not just thermal comfort, not just indoor air quality, but putting them as a whole, as in perspective, as they all interrelate, to how the system's functioning.
No, you're exactly right. And of course, what we've seen leading up to COVID is that, a lot of folks were operating in deferred maintenance mode. They weren't able to address some of these conditions in a timely manner, whether that was from a manpower standpoint or a budgetary standpoint. And then COVID hits and buildings are put in setback mode, and some of these conditions are even exacerbated to a further point of degradation. And right in the middle of a pandemic, or as we're trying to bring these buildings back online for partial occupancy, to get back to work, back to school. And so when we look at inspection and maintenance, I do think, as you were mentioning, the indoor air quality aspect of that guidance, we have to look at baseline testing and inspection, right? And what does this involve outside of that HVAC hygiene assessment or performance assessment? But now what does it look like outside of that into the occupiable space or the building envelope? Like, how is the HVAC system actually affecting where the people are going to be, right, when they're coming back to work or school? And so what we do at Pure Air Control Services is we have a program called the Building Health Check. And this program can be a la carte. It can be very specific to like a forensic level investigation of a particular area, or we can look at the entire envelope of each building across a campus or portfolio of buildings. And Carl's actually, I got to call him out here, Carl's actually pictured on this slide doing a little bit of particle readings in a laboratory to make sure that the particle load in that room is sufficient and within guidelines. But Carl, can you explain a little bit about what goes into these building health checks?
Sure. And Troy, I think you made the excellent point. We right now, there's a focus on ventilation and correcting the HVAC systems to improve air changes and the overall air quality in the building. But how do we actually prove that that's effective? How do we actually document what a person might be exposed to, or kind of take another means of grading the changes that have been made, not only to take a step back and reassess and make corrections if needed, but also document, hey, if we have made these changes, hey, these are effective and here's our proof of it, right? So, to me, those are two very valuable means or tools to have. And that's essentially, what our baseline testing inspection is based around. It's taking a look overall at a lot of these air quality constituents and surface quality constituents that indicate, where hygienically the environment is, and that relates to things like how well the air is being filtered, how much turnover and air changes are we getting, what's our pressurization. So a lot of these come back to how the HVAC system actually is affecting that indoor environment.
No, yeah, that's a great point. I mean, keeping an eye on CO2 and how it's moving through the building, temperature, humidity, looking at these other contaminants that might be within a building, right? Allergens or bacteria like Legionella, which we'll talk about here later in the presentation, mold, all of these things. And it bears mentioning that our Building Sciences Division, in conjunction with our Environmental Diagnostics Laboratory here at Pure Air Control Services, can provide environmental coronavirus testing, both airborne testing and surface testing, and that can be included as part of a building health check. So, once you assess your baseline and you put that in your plan as taking the corrective actions to make sure it's sufficient for folks to get back in the building, once they come back and they're working back in the office, or maybe again it's a big box store, it's a grocery store where they've never shut down, much less the hospital, right? We can continually monitor that indoor environment using our IAQ guard system. And very briefly, we've touched on this before, but you establish that baseline condition, and then to maintain it, you just keep an eye on it, right? And this is done with a series of what we call nodes that have many different sensors within them, and they're Wi-Fi enabled. You place them throughout your facility, and they monitor for CO2, particulate, so PM 10 and PM 2.5, I believe, Carl, VOC, relative humidity, and temperature, right? And it sends all of this logging information up to a cloud platform, and that's done either via your local network, or if you're in a high security network, then we can establish a cellular router that's dedicated to this system that will then take all of this information to a browser-based dashboard user interface. And there you set your parameters, and you can set and send alerts if any of these areas start to go above the threshold that you set. So it continuously logs this data. At any time you can access the history of this data should some sort of incident occur. And then of course you can slice and dice this data any way you want and generate reports that are either automatically generated or custom generated, which is useful in helping keeping up with certain compliance, or if there's an OSHA related issue or there's an outbreak in your building, you can have instant access to what these basic indoor air quality parameters were in that slice of time. So it's a very helpful program. A lot of our customers are finding it very useful in their buildings, just to keep an eye on things and to give confidence to the returning employees or customers. We've had, some of our customers actually display this on a screen in their lobby so that their employees, as they're coming into the building, can see that everything is in good baseline condition. So very interesting and cutting edge technology that's being deployed widely right now, not only because of the pandemic, but just again, to stay in compliance with the well building standard, LEED, and other things that are happening. So this 1-2 punch of a building health check in combination with IAQ Guard kind of hits on 3 key areas that sort of fit in with this ASHRAE guidance, and that's keeping an eye on how these HVAC systems are performing within the building. And so again, we're going to look at really briefly here relative humidity, particulates, and CO2. So Carl, why don't you jump in here as an industrial hygienist with that cap on and give us a little overview of these areas.
Right. So, yeah, I mean, one of the things that our HVAC systems are intended to do is help us maintain adequate temperature and relative humidity conditions. And we're not only talking about a occupant comfort, right? Too low, we can get drying mucous membranes. Too high, we can get fatigue, irritation. Same thing, you know, temperature is also just as important with that, but humidity also is very vital for microbials and controlling microbials. You can see there, maintaining that humidity between 40 and 60% minimizes the risk associated with them basically proliferating, especially when you get above in more moisture latent conditions. So it has you know, it's why testing, you know, a lot of times when we do a baseline, people go, oh, temperature and relative humidity. Well, it's actually very, you know, key and a key component to not only understanding how the HVAC system is functioning, but how your building's going to wind up in terms of overall environmental conditions and comfort conditions in there.
No, exactly. We know that COVID-19 or SARS-CoV-2, the actual virus that causes this illness, is airborne. I mean, there's no question about it now. You know, I very rarely like to use the term the science is settled, but it really is in this particular case. That's why masks are still being recommended, social distancing. And so I think, you know, we look at how this virus is spread from an airborne perspective, and we know now through these various research papers that this virus, or the droplets that the virus is contained in, can definitely cluster with other particulates that are airborne and hitch a ride, if you will, to be spread further into the building or the building systems. Is that right, Carl?
Right. I mean, you know, what we're looking at right now, you know, I'm up here in the Northeast, and we have our standard particle load in buildings. And, you know, speaking of coronavirus, right, we know that lower humidity can result in these tinier particles in the air of the coronavirus. It can, you know, the science is there. It can become more of an issue for spread and risk associated with it. But, you know, in general, we have to consider the full gambit of particle sizes. You know, coronavirus definitely a key focus. Understanding that we can utilize, you know, particles. Many folks are using particles in the PM 2.5 range, but you can get down particles of 0.3 micron and below, knowing that, you know, coronavirus is associated with 0.1 micron. And we can test around those different particle sizes to understand how well our building's filtration is performing. And if it's lower counts, our filtration is hopefully, you know, performing well. And that's a great indicator, you know, that we have some better control on capturing and removing particles. That could be the coronavirus size. But more importantly, we have to think about it in terms of the other constituents, right? We're going to eventually get past this coronavirus phase, but we're not going to get rid of the other air quality constituents that come in all the time. We have molds, we have pollen in the spring and summertime. So we have these other irritants and allergens, and it's important that our filtration and the cleanliness of our building, you know, help us maintain low counts of these for the future, right? So we don't want to have, you know, those classic complaints of itchy eyes or a cough or some sort of irritation, because now we also have that fear that we're going to be carrying with us for years to come, you know, based off of this coronavirus pandemic. So I think particles as a whole and filtration are key right now, you know, beyond just kind of understanding the baseline, but using that to basically make corrections and improve your air quality.
No, that's well stated, Carl, and particulate is so important in assessing your systems, like you said, infiltration, you know, not only into the building, but maybe even filter bypass, which I think we might talk about or touch on, you know, down the road here in this presentation. But then the final sort of indoor air quality parameter that we want to look at here, again, both through our baseline building health check inspection and then ongoing monitoring like IAQ Guard, is, you know, CO2, carbon dioxide. maybe hit on this a little bit too, because I think CO2 is a really good measure of how well your ventilation system is working, especially when you're operating in occupied mode.
Sure. Yeah, I mean, it is relatively self-explanatory there. I mean, CO2 is a classic indicator of your your ventilation, your circulation, how well our HVAC system is performing when the building's occupied. And see, we know CO2 as it increases in level up there into 1,000 parts per million range, it certainly can become its very own air quality pollutant in a way, and cause adverse symptoms for our occupants. Studies on cognitive function, for example. But it's an excellent, easy indicator, though, to understand how well your HVAC system is diluting the air and bringing in that fresh air. So it's an easy way to quickly measure and understand, hey, is there something wrong with potentially my HVAC system and the outside air coming in? And going back, even same thing with the particles. Another way to understand, we make these corrections, but okay, I upgraded my filters, but do we have bypass in my filter bank? Do I have loose gaskets in areas where outside air is infiltrating? There's a lot of these basic air quality constituents that help paint a much bigger picture and allow us to act proactively, for sure.
No, that's exactly right. And so as we move sort of from the inspection phase of ASHRAE's inspection and maintenance guidelines, we're going to get into maintenance a little bit, right? And so speaking of particulate matter, we've been around since the mid 80s. We've cleaned thousands and thousands, hundreds of thousands of feet of ductwork, right? And we see this kind of particulate buildup in these air conveyance systems, right? So as part of your maintenance plan and as part of your inspection plan, you should be looking at this air conveyance system. You should be looking at the cleanliness of the ductwork, and you should be cleaning it. I mean, it really goes without saying, and for a number of reasons, but not only for this particulate and an indoor air quality standpoint, but if there's extreme fouling or buildup, it can also affect the equipment that is oftentimes located inside of the ductwork and is oftentimes forgotten about. So what kind of considerations do you want to take in when you're talking about contracting duct cleaning if you're not doing it yourself? And of course, you're going to want to have a detailed specification. You're going to want to know, have blueprints of the ductwork, know where all of the mechanical equipment inside the ductwork resides. So you're going to want a detailed spec, not only of the equipment, but how you want it cleaned, right? So you want to require that these duct cleaners, like Pure Air Control Services, our Building Remediation Sciences division, right? You want to make sure they have a mechanical background or are mechanically licensed. Inside of a pandemic, it would probably be a good idea that they have environmental experience and they're not just getting up there and vacuuming ducts, right? That they would have environmental experience to know the proper PPE, the proper equipment, the proper containment. So that being said, they should be NADCA certified and perhaps even VMSR certified, as we have been in the past. I understand NADCA sort of dropped that ventilation system mold remediation certification, but know that we have been that in the past and continue to operate at that level. And then, of course, what kind of equipment and process is being considered. So without getting too far into the weeds here, at Pure Air Control Services, the first thing we're going to do is set up containment, like airtight containment, put the entire segment of ductwork we're working on under negative pressure, taking all of that into a negative air machine with HEPA filtration, right? We're going to monitor those particulates as we're cleaning the duct to make sure there's no cross-contamination. And then basically it's the tried and true strategy. We're working from the return ductwork to the air handling unit and then back out into the supply. So again, we use HEPA filtered NAMs. We HEPA vacuum, then use compressed air brushes, right? And it all goes through that negative air machine and into the HEPA filter bank. We are going to encapsulate the duct board if it shows signs of degradation, to lock that fiberglass in and prevent any of those fiberglass particles from traveling into the occupiable space or into your filters. Or we could actually replace some of the fiberglass as part of our new life restoration process. And then of course we have a disinfection option, and a lot of duct cleaners won't do this, but we're able to use list-in EPA registered disinfectants to basically fog the ductwork for any of this viral contamination, bacteria. And then of course, as with all of our processes, we issue a very detailed report on what we did that includes a job log, pictures, any kind of environmental sampling we did. So you have a nice buttoned up report to put in your maintenance files to show the exact process of what we did, how we did it, and where we did it. So again, it's a very thorough process. And here's a couple of pictures that we chose specifically based for this ASHRAE topic to show that there's equipment inside of this ductwork that helps control the airflow and ventilation out into the occupied space. If this equipment gets fouled, it can affect its mechanical performance. It might seize up and not be able to close all the way or open all of the way, as you can see in this turning vane damper, right? Or something might happen like a filter bank disintegrates, like as in this picture, or just normal fouling occurs inside of a reheat coil or inside one of your VAV terminal boxes that creates serious impaction to airflow and then restricts the ventilation and airflow that's being put into the occupied space. So, ducts are not to be overlooked. They should definitely be considered in part of this inspection and maintenance planning that ASHRAE is recommending. And of course, we know this, right? Just a little bit of dirt makes a huge difference. And this study from the Environmental Protection Agency from a number of years ago, I think still holds up with all of the reporting and different things that I've seen from the field brought back into the office here. But only 3/16 of an inch of fouling across the evaporator coil can decrease the performance of that coil by 21%, right? So now, again, it's being impacted, airflow is being restricted through the fins of the evaporator coil, and this creates, an insulating effect on these fins, right? So that now the main function of this cooling coil to transfer the coolness from the fin to the air as it's passing through it. Now this is even lessened because it's insulating that coil and not letting that cooling effect happen at the optimal efficiency. So that's why, again, we recommend looking at these coils and systems and being able to clean them at a very high level, at a disinfecting level, not just doing a tertiary cleaning with some foam or having a foam system and having it pulled through, but actually going in and removing this deep impaction within a coil. And again, these considerations that you'd want to take into account, especially with a service like our Pure Steam AHU coil cleaning service, is that it be eco-friendly. We don't use any chemical agents. We do use some bioenzymes that are eco-friendly. In fact, we're Green Clean Institute certified. Again, you want someone with a mechanical background that knows how to operate within these systems safely and is not going to damage these systems. You would want someone with environmental experience, someone that's going to do some basic testing to find out where these coils are impacted and at what level. And then, of course, someone that has proprietary equipment for each job type, because we know that, there's no two coils that are exactly the same, even if they're spec'd the same. There's no two, air handling units from building to building that are the same. So you would want to know that they have different sized equipment for different sized coils. And then, of course, that you're going to get a deep clean, right? We have a 14-point checklist in our Pure Steam process that each one of our technicians goes through for every coil that they clean. So again, much like doing our duct cleaning with our Pure Duct service, with Pure Steam, we're setting up full containment protocols. We're going to do what's called a coil cleanliness verification test, where we take an air blaster fan and we look at the pressure blasting back into the fan to see what areas across the coil are most impacted. And we'll take that test. There's a matrix that we give our techs so they know what areas to work. And then after we're done cleaning it, they take the test again to make sure that we removed that fouling. We're going to HEPA vacuum the entire interior of the AHU, steam up to 350 degrees Fahrenheit to sanitize the coils. And up to or around 350 PSI. So this isn't a pressure washer. We're not going to destroy the fins. We have proprietary tips on these steam units that are made for cleaning these evaporator coil fins. So we're going to maintain water extraction, so none of your drain pans overflow or your pipes or plumbing overflow. And then we're going to flush it at the end with 55 gallons of water per minute to be able to get rid of that latent debris. And of course, again, we have a full detailed report with all of the measurement and verification testing pictures, and then any kind of environmental testing that might have been requested at the time. So it's a very thorough process. We've seen coils that basically weren't passing air through them brought back. Here's a very quick white paper that we did in conjunction with the Continental Automated Buildings Association, and I'm not going to run through this whole white paper, but suffice to say that in this study, Pure Steam was found to be 99.98% effective against microbial contaminants and disinfecting the coil with, again, just water, steam, high temperature steam, right? And we improved the airflow in these coils that were tested as part of this study by 36% and air velocity by 37. An in-field example from this case study from Georgia Tech University saw a 42% improvement in cubic feet per minute and about 46% or 7 tons of cooling capacity added back to this older unit. So highly effective. We can also disinfect the coils by fogging them with a list-N disinfectant if that would be required in the case of maybe an outbreak or a hospital. So, you know, we have a very versatile toolbox within our Pure Steam set to be able to basically handle any type of coil, any type of air handler unit or situation. And then building upon that, which we won't get into a lot today, but we offer an HVAC restoration program called HVAC New Life, and that includes everything that I was just explaining about Pure Steam, but it goes on to be able to refinish the cabinet, the coils and drain pan with antimicrobial, antiviral tested, this coating tested against a coronavirus surrogate and found to be effective, and water resistant coating. Right, so these coatings can come in, recoat the drain pan, the interior and exterior of the cabinet, all of the filter rails, everything, right, to make it more resistant to any viruses and bacteria that might get inside of that unit and come to rest on these components. You know, of course, we can also retrofit these old blower units with an ECM fan array. So these have seen rise in popularity. It adds redundancy to the unit. So if one fan goes down, the other fans in the array will ramp up to provide continued service. This is especially crucial in hospitals that we have this built-in redundancy in manufacturing plants, food processing plants. Again, it's more sustainable, extends the lifespan. And here's a big one when we're talking inspection maintenance for this ASHRAE program is less disruptive than replacing an entire unit. So we can have a crew of less people over less time with less disruption to the building come in and restore and clean these units than it would be to actually shut an entire unit down, take it out of the building or off of the roof and put a new building on. So really important stuff. I know we're kind of getting into the middle of this thing. So, you know, the last few slides after these next two sections will go pretty quick, so please bear with us. But again, I think the main focus of all of this ASHRAE guidance, when you move past the inspection and then maintenance, you know, so once these systems are now running as designed, is ventilation and filtration. And there's been a lot of emphasis on this, air change rates and having adequate ventilation. So Carl, why don't you take us through what ASHRAE is saying here a little bit about ventilation and filtration.
Well, you know, I'm sure everybody's caught the bullet point with MERV 13. You know, filtration has certainly come up at the very front of things. It's a pretty quick and in-house solution, right? So, you know, one of the big components here to ASHRAE underneath of it all is how do we deal with this in-house and combine with professionals in the field to attack this, you know, broadly. And you know, here's a great example. You know, many of you are doing your own filters. And MERV 13, stepping up in general in your MERV rating is an air quality improvement period, right? Disclaimer for those, hopefully nobody in this has learned the hard way, but always reference your HVAC manual, your unit's limitations when it comes to MERV filters. We have various ages on units, and we have to keep in mind that can be a limiting factor on what filter they can handle. Too high of a filter, you might be having some issues soon with burning out your motor and basically stopping the ability of your unit to run, period. So just keep that in mind. ASHRAE makes a valuable point, though. They use MERV 13 as, hey, let's try to upgrade our filters to MERV 13. Why? When you upgrade your MERV filter, essentially what you're doing is you're increasing the ability to capture some of the similar air quality constituents that lower MERV filters could capture, but you're doing it with higher efficiency percentage, right? So MERV 8 versus MERV 13, you're going to capture a greater percentage of the same type of air constituent. However, you're also now moving into things like bacteria and viral carriers. So that's why 13 really kind of shines, as we start to have a little bit more ability to capture those. However, another disclaimer, please, keep in mind this isn't your cure-all, your bee's knees. Hey, we did MERV upgrade, we're good to go. It's one of many tools in the toolbox, as ASHRAE kind of suggests that we should have. So, we have filters. Obviously, that goes hand in hand. Ventilation, we want to be bringing in outside air. We want to be changing, ASHRAE wants you changing over the air in your room or in spaces, quite commonly. Personally, what we like to see is a 3 to 5, but remember, with air changes, it depends on the space, the use of the space, the occupancy. But in general, we want to have an increase in how much ventilation, how much air changes in air quality or overall air volume we have coming into the space. Now combine this with air cleaners, right? So we have the MERV filter situation where we're filtering out air, but what happens to some of those particles, those constituents that are still coming downstream and into the space, right? This is why we say it as tools in the toolbox. And a MERV filter a MERV 13 isn't gonna solve everything. How do we address those that are coming into the space now? And that's really comes into utilizing air purification, air cleaners to help exceed this minimum upgrade and enhance our ability to combat not only coronavirus, but to also minimize air quality associated risk.
No, you're absolutely right. And so, obviously the main focus lately, you've seen a lot of discussion on this in other seminars and conferences and on LinkedIn, everywhere, right, is this bipolar ionization and being able to put this needlepoint bipolar ionization technology within your HVAC system or ductwork and allow this, bipolar ionization to work within the occupiable space as well as within the air conveyance system. And so there's different kinds of equipment for different kinds of situations. And so pictured here are some of the things that we make available to our customers through our Pure Plasma program and bipolar ionization equipment. And so just really quickly, you can see what's referred to as a needlepoint bar. And this bar goes across the entire span of the coil. And then it produces these ions that are taken out through the air conveyance system and into the occupiable space. Number 2 is a needlepoint brush setup. And these are typically put on the blower and then is circulated through the space via the blower. These are for smaller type of units. And then of course you have like a needlepoint ionizer or tube, which can be mounted within the ductwork. These devices can be always on. They can be configured to switch on and off as the AHU powers on and off, or they can be controlled through your building automation system. So again, we could deep dive an hour into any single one of these categories. So I know we're moving quick. The slide deck is attached as a handout. So you can download that handout as a PDF. And of course, we'll be here to answer your questions as we wrap this up, or even you can email us, and we're happy to jump on a call or even do a custom webinar for your organization about any one of these topics at any time. So basically, bipolar ionization works like this, right? It produces negative and positively charged oxygen molecules. These oxygen molecules are produced in the millions. They circulate through the ductwork in the building, where they interact with a various number of constituents, different airborne particles, microbes, VOCs, gases. And so since the particles are charged oppositely, they're always traveling through the space looking to find their equal opposite or another molecule to bond with. So in the case of coronavirus, and this has been proven, our own laboratory has an environmental test chamber. We've actually looked at almost every single competitive device on the market today and looked at the efficacy of them to varying degrees, and they all work. And this is how they work, right? So the oxygen molecule, positive or negative, goes out into the occupiable space and finds, in the case of coronavirus, the hydrogen molecule that's on that cell or in the droplet, right? And so it bonds with that, effectively stealing it away from the virus. And without that hydrogen molecule, the virus becomes inactive. And that's the simplest way I can explain it. It also will attach itself to the various molecular constituents of the VOCs, and it breaks down their structure. It works the same way to neutralize noxious gases or smoke, which is why this has been widely used pre-pandemic in casinos or other places that still allow smoking, or other environments that might have odors in them, right? And then finally, what it does is it makes a lot of these particles cluster together or clump together, so they're more effectively trapped in these MERV 13 filters or even lower rated filters. Another air cleaning technology that we do at Pure Air Control Services is what is called a localized solution or in-room solution. So where bipolar ionization is systemic in that it's in the air conveyance system, these units that we've partnered with Aramax, our Pure Plus Aramax program, right, are in-room solutions. So there's different sizes for different sizes of rooms. They have a multi-stage filter system. They offer true HEPA filtration. They actually have a little mini needlepoint brush system in there to create bipolar ionization at the room level. They're EnviroSmart, have PureView technology, and have quiet operation. So EnviroSmart means that they turn on and off when they sense a higher particle load or some movement in the room or activity, and then will turn off when the room is still or there's no activity. So basically, again, this is the multi-stage filtration that we're looking at. So it has a pre-filter, a carbon filter, the HEPA filter, and then in the blower stage, they have its own bipolar ionizer to do what we were just talking about. And of course, this HEPA filter also has an antimicrobial coating and has been certified or verified that it's capturing at 0.3 microns at the particle level. These filters need to be changed about once a year, every 18 months. With bipolar ionization, unlike UV light, it is always working. It's working within the room, and it requires no maintenance whatsoever. So there's no bulb replacement or anything like that for these needlepoint devices. And so again, once your ventilation is in place, your filtration is good, and then you're also using the recommended air cleaning equipment to exceed those recommendations, we start to talk about pre and post occupancy flushing. And again, this was also a big part of the conversation last autumn in 2020, as we became more and more aware that this was an airborne event with the spread of this virus. Carl, why don't you take us through what this flushing concept does?
Sure. Essentially, what we're trying to do with the flush is recirculate the volume of air in the building. As you can see here, we mentioned 3 air changes of outdoor air as a minimum. I mean, again, different spaces have different bottom line requirements, but the overall way to look at the overall goal is to bring the quantity of fresh air into the space to replace what was in there several times, and get rid of any of that bioburden through that process of bringing in the fresh diluted air, filtering out, removing the existing dirty air, and creating then a fresh space. And it goes again, as you mentioned, Troy, it's another tool in the toolbox, right? It's another means that I recommend, that obviously is recommended in addition to the other types of filtration. Now, of course, this does have some dependency on a nice central system, and for some of you, that's going to be not quite the case. We have schools, we have classrooms without any sort of central system. So, that's why there's those other means of removing the bioburden through a filtration, through air changing. So there's different ways to look at it, but this is one that's comes pretty highly recommended here to perform.
That's exactly right. We have customers in your your region, Carl. You're based in the Philadelphia area, so all up and down the Northeast Coast, Mid-Atlantic, and in the plains that don't even have modern centralized air conditioning systems. They're still operating boilers and using radiator heat. Carl and I was actually on a call maybe a week or so ago when we were talking to folks at a school up there in the Philly area that said, what do? We can't even open our windows. It's 20 degrees outside. And we don't have a central air system to be able to do this flushing or to improve the ventilation. And so they were looking for other options like these in-room air purifiers, or even maybe a more industrial option to move air and filter it, like these industrial HEPA air cleaners or air purifiers. And again, much like those wall-mounted units that we were just talking about, these operate at much higher CFM with a much larger filter system. And we can also put our pure plasma bipolar ionization technology in these, but these are good solutions when you have a larger area, or maybe you don't have the ability to move air because it's the winter, you can't open windows and such. So Carl, I mean, what do you think are good applications of these type of bigger devices?
Right. Yeah. I mean, these have their purpose in your larger volume spaces. When you get, so a lot of you may have already purchased some or been looking into the localized smaller filtration units, which are great for a multitude of spaces. But when we get into a much higher volume or a larger square footage, very tall ceilings, we really want to try to accommodate that by moving a substantial amount of air, cubic feet per minute, to achieve those actual air changes. And sometimes the smaller units don't necessarily cut it. That's when the larger units like this come in. So it's really about understanding where you want to put filtration, and then working with somebody like ourselves to strategize. Okay, here's our volume of space. We can accomplish it through this style of purifier, versus here's another space. We need to use one with a little bit more horsepower, a little bit more firepower, really, because the end goal is still the same. We need to, exactly with this one, we need to account for ceiling height. We need to account for the overall square footage and make sure we're properly, the right size unit is in there. I mean, it is so important not to undersize the unit by any means. And you can do some redundancy with smaller units, but still, there will come a threshold where you have to start to consider, okay, we need a little bit more of a larger unit, more substantial change power.
No, you're absolutely right. And so we move up from these wall units to these industrial sized floor units, and then even to a giant beast like our Pure Blue, or we call her Big Bertha sometimes. But these bigger true HEPA large volume air cleaners, right? And so we've seen these type of devices deployed at like big box stores that have stayed open, and like your Home Depots, your Costco's, grocery store chains that have been concerned but have stayed open, and they still have customers coming in and out. We've seen them used there. This particular image right here was shot in the trade show floor, the convention center floor of the Jacob Javits Center in New York, where we went up into the Javits Center after they were being decommissioned as a field hospital with FEMA and the U.S. Army Corps of Engineers, and being put back into a public event space. And so we used this device to basically flush the air out at a high volume, not only while we were disinfecting the entire space, but also just as one final flush before, they certified these spaces being ready to be occupied again. So again, this can move large volumes inside of field houses, gymnasiums, convention halls, hotel meeting spaces, things like this that is a very, very big room. And so, that basically covers the inspection and maintenance phase. And really, when ASHRAE is talking about water systems as its separate category, right, you're still really kind of lumping that in with inspection and maintenance, right? But because it's not part of the air conveyance system, I think is why, they really look at it as a separate building system, that because, cooling towers can have any sort of constituent that's in the water become aerosolized. Other faucets and showers and things within a building can aerosolize any kind of contaminant that's in the water system. I think they bear special focus to the water system. So again, much the same way they recommend flushing the air, they're recommending that you flush your entire building water system, prior to reopening that building, especially if that building was put on setback and was largely unoccupied for many, many months, where that water could just be sitting in there stagnant. And this is both for your cooling system and then probably your also potable water that is in your system as well. Myself and Dr. Rajiv Sahai, the director of our environmental diagnostics laboratory, has done many dedicated webinars to Legionella, Legionnaire's disease, Legionella, bacteria, and water systems. So I encourage you to go onto our YouTube channel, Pure Air Control Services, and take a look for those webinars if you want more in-depth information on Legionella. But that's sort of what we're looking at here. And we've seen this, it's been in the news cycle ever since this pandemic started and these buildings have reopened, are new Legionella outbreaks because this water has sat and stagnated or hasn't been given enough attention to. So of course we know it's ASHRAE standard 188 2018 that you want to go into detail. We offer a Legionella handbook that helps you create a water management plan and understand Legionella and the importance of it. So you can feel free to contact me or Carl. We're happy to send that to you free of charge. It's a nice little handbook that you can keep in your desk drawer. And I say all that to say that one of Pure Air Control Services divisions is Environmental Diagnostics Laboratory. And they're an A2LA accredited lab. They're part of the CDC Elite program for Legionella for many, many years now. And they're also certified by the New York State Department of Health through their ELAP program for Legionella and heterotropic plate counts coming from water samples. So basically, they do Legionella testing back to front, and they can do the three main tests that are associated with Legionella, and that's the non-culture method, which is fairly rapid, right? And they're going to look for the antigen identification. They can culture the actual bacteria or the water sample to see if Legionella is growing and culture it, and then they can actually look at IDing it that way. That's a little bit longer of a process, and that's about 10 to 12 day turnaround. And then of course, they can use DNA amplification or PCR technology. And this is the very same PCR technology that they themselves and even clinical laboratories are using to test for coronavirus. So when we started doing coronavirus testing at the molecular level inside of buildings on surfaces and in the air, this PCR method of polymerase chain reaction, it was not new to us. We're highly experienced in using this method of testing in our laboratory. And so again, water systems are important, something that you might not think of right off the bat, but that are equally important to monitor. And then of course, once you've executed this plan, your inspections are complete, you're moving forward with corrective action and maintenance, then you're always wanting to, at every step of these recommendations and guidelines, keep an eye on your energy savings, right? Because so many modern buildings and airtight buildings have gone through great lengths to become more energy efficient, right? And in the coming years, as we look towards sustainability again, and with more green initiatives, this is going to be ever important. We know there's some energy efficiency loss by bringing in more outside air. So looking at your controls, how they're set to accommodate for this outside air being brought in is particularly critical in maintaining this energy savings. And I will say this in closing, that we were at a hospital site in New York City doing a lot of steam cleaning. I think it was over 33 air handler units that were all about 35 years old. And the control system in that hospital was reset to accommodate how fouled these air handling units were and the airflow that actually wasn't going through these coils. And when we were done cleaning the coils, the building manager, the person that was in charge of the controls, didn't think to reset the controls. And actually one of the outside air dampers collapsed on itself because of the improved airflow that we brought back to the system via our pure steam coil cleaning. So again, for engineers and building managers that have set their controls to accommodate deferred maintenance to this is a very critical area as you're working through this process during COVID-19 and keeping your buildings open to keep an eye on. So again, I know we ran over here just a little bit, about 8 minutes or so. We're going to be looking at questions here, but just so you know, COVID-19 isn't our first rodeo. We've been firmly entrenched on the frontier of pandemics for a long time. We were founded in '84. We've been through SARS-1, MERS, H1N1. We've developed a lot of the protocols and methods we use from things we've learned during those pandemics. So you can have a high level of confidence in us that we know exactly what we're dealing with from an environmental standpoint and how to mitigate for it and manage that risk. Again, we have 3 specialized divisions, Building Sciences, ED Lab, and Building Remediation Sciences, all told 700 million square feet and over 12,000 buildings. We've worked in just about every kind of commercial building or institution that you can imagine, and we continue to do so to this day. So again, I'd like to thank you for joining us today. My name's Troy, and Carl was with me. Here's our contact information, and we're open for some questions right now. And I do see we have some that were typed in, so let me take a look at those and see if we can get some of these answered. Of course, yes, this webinar was being recorded, so if you like, you'll be able to go back and view it again in the near future or share it with colleagues. We can also replicate this webinar or any one of these topics in depth for your organization. If you want to reach out to me or Carl, we're happy to schedule a meeting with your team and take this through you, or take you through this customized to your organization, of course. So we have this. What is your opinion on bipolar ionization with respect to virus disinfection? And that's from Bob P. Triangelo, if I pronounced that right. And I think we kind of covered that in real time a little bit with how bipolar works. And as you can see for this whole presentation, and then even in depth with our Healthy Building program, there's no one-size-fits-all solution, and there's no sort of magic bullet that's going to take care of this virus. It's a combined approach, a sensible, engineered, combined approach that is going to be most effective in managing this risk and keeping occupants safe as they come back into the building. So yes, we've seen many different bipolar ionization devices. We've tested them in our environmental test chamber on site here at our headquarters, and we've seen pretty high efficacy from all of the devices. Some work better than others, but they all seem to have a very high output and are doing what they say that they will do. My understanding, and this is from Michael McGinnis, my understanding is there are no EPA registered disinfectants for ductwork. Carl, I mean, what do you know about this? You've been on the job site a little bit and have seen how we sort of will dry mist the ductwork, and that might be part of the answer to this question, is the dry mist or electrostatic mist. But what do you think about that?
Right, well, touching on the wet dry, I mean, where you fall into with the ductwork is utilizing one of the EPA registered disinfectants, but applying it in such a way that you get a coating on the ductwork and allow it to have its dwell time to correct. And it should be done just like you would a desk or a surface. It should be done on a clean ductwork where we have, open, free area, free of debris, free of particulate. Now you can use it, Troy, back to kind of that idea as a dry fog, as a means of kind of a surface disinfection, a light surface disinfection of the ductwork. But again, it's the idea behind it is we're utilizing a product on a surface. It's not specifically designed for ductwork, but it is a fog that's designed, or created, a solution that's created, I should say, to combat viruses, bacteria, mold, and it's EPA registered and approved. So it's just utilizing that within the ductwork, but applying it properly, right? We can't also saturate internally lined ductwork or fiberboard. So it has its application and its correct use, which is one of the big reasons we strategize with you if we have to do that type of work, to make sure we know what the layout is, how we're going to apply it, what's going to be, kind of the pros and cons of it.
Yeah, that's correct. We're using list-in disinfectants and primarily in an electrostatic spray method into the ductwork that forms a dry mist. Again, these are predominantly hydrogen peroxide silver-based or ammonium quaternate based disinfectants. And of course, we're doing this work or performing this work under strict containment and PPE guidelines, as well as when the building is not occupied. And using proper dwell time. It also bears mentioning that we have a full HVAC training facility here at our headquarters that all of our techs go through and train on each one of these methods and all of the equipment that we use and deploy into the field. Further, again, our environmental diagnostics test chamber, right, our laboratory's test chamber, we test the efficacy of all of these devices that we are using or modifying to make sure that they're effective. Here's a good question, Carl, from Robert Morton, and he's asking, does Pure Air Control Services use the Pure Steam process on PTAC units inside of dorm rooms or residential student housing? And the answer is yes. One of our Pure Steam devices that we use puts out a dry steam, right? So it's not a full wet or flush steam. So we're not going to worry about flooding these little units or flooding the dorm room. And we're able to very successfully clean those units, as well as chilled water fan coil units that we often see in some of this residential student housing, or even in resort hotels in the rooms. And in fact, we have a video on our YouTube channel that shows the process in detail of how we're dealing with chilled water fan coil units, particularly in a hotel. So very small units and how we sort of disassemble them and clean them out very thoroughly and put them back together and put them back into operation. So yeah, we can absolutely do that based on your spec, no problem at all. We do, Stephanie Corbett asked us if there was a summary slide of the 8 pillars. And that was the initial slide that we had with the background, and that was that ASHRAE Guidance for Reopening Buildings PDF. And so, Stephanie, I can email you that. I didn't want to distribute that document en masse because that's ASHRAE's document, copyrighted document. So we're speaking to it, but certainly that document, I can email you a link to that document as found on ASHRAE's site, not a problem. Carl, maybe you can do this. Have you tested coils to see if ionization actually cleans the coil versus UVGI, which 100% cleans the coil? That also is from Bob Pietrangelo.
Right. So, I mean, you can certainly test both of those. The question would be, where in the coil, right? We know that UV will get our surface with a slight coverage just past it, so you could test obviously the surface where you'd anticipate, very close to, if not sterile conditions, but you could test with a swab actually several inches into the coil, and you could test the downstream side of the coil to see what kind of effect of those systems have. Now with UV, you would probably be more limited to that surface test. With bipolar ionization, you can apply it or you can install it on the filter rack pre-coil, and the ions will not only interact with the surface, but they will, run through the coil and down into the fan chamber and out through the ductwork. The only disclaimer there is UV will focus on more of a broad coverage of that entire coil, whereas bipolar will have some limitation. It's not going to come out at a perfect area to cover the entire coil. It'll probably be a little bit more focused in a certain area. So you would want to account for that as part of the testing for efficacy.
Yeah, that's true. We actually have it's a pretty light case study or explainer example that I can send to you, Bob, as well as the benefits of the pure steam cleaning in units that also had UVC light in them or UVGI light in them that showed remarkable improvements through the coil and other areas within the HVAC system that perhaps were shaded from the wavelength of the UV light. So underneath the coil, underneath drain pans, on the backside of rails where the light wasn't actually able to penetrate or touch. So, again, there's no one magic bullet, and all of these technologies are on the table with regard to, looking at various methods of improving the environment. Bob also asked the question as what does the research say about ions affecting humans and plants and or pets, since they are made up of single cells as well. So, I don't have all of that research material at my hand. I can definitely have Dr. Sahai email you to continue that line of questioning offline. And like I said, we're happy to jump on a call with anybody and discuss any of this in detail. What I can tell you is from the research that I've seen is one of the biggest factors that have been a concern for these bipolar ionization devices has been ozone, right? And I can tell you that of the devices that we use and most that we tested, the ozone output is very little to negligible, and certainly well below the 0.05 recommended ozone output of the state of California, which has the most stringent guideline on that.
And to add to that too, just backtracking too, because Bob, you had a couple good questions. Never overlook the combination of UV and bipolar ionization, kind of what Troy was saying earlier. There's no one silver bullet, but it's a combination attack of tools in the toolbox. Two, keep in mind that ions are also naturally generated. Think about the mountain environment. When you take a shower and you finish a shower, there's a huge concentration of ions generated. So these aren't some sort of science lab created product. It's a recreation of what you will find out there in Mother Nature. And the devices are designed to put enough ions into the space, but it's not this overburden of ions coming in when folks are in the building. I mean, this has been thought of as part of the manufacturing, part of the delivery of those concentrations. If you really want to get into it, you can read into how folks look at negative ions and their effect on mood and things like that. There's some literature out there back and forth on negative ions and that. But overall, no, this isn't something where, you were kind of thinking more along the lines maybe of like locking yourself in a small room and, dumping billions of ions in, then the question of, what happens can be brought up, but not necessarily with these products. It's different.
Robert Morton also asked the question, is bipolar ionization effective in PTAC units? And again, the short answer is yes. If you think about that in-room air purification device that we were talking about, the Pure Aramax that mounts on the wall, those are very similar to how the PTAC units work and function, and they have a little needlepoint brush ionizer that's in and amongst the blower in that device to help supplement that HEPA filtration and everything. So yes, PTAC units can be retrofitted with the bipolar ionization to not only help keep the residential housing room, the dorm room clean, but also help with knocking down some of that constituent within the PTAC. Of course, we'd have to look at the specifications of each unit, and oftentimes, we can actually partner with maybe even the manufacturer to make sure we have the right spec and input and output voltage and all of that stuff. So, but it is possible. We have been retrofitting different sized units with our bipolar ionization or pure plasma. Here's a good one from John Yao. He was asking, can you review the impact to the airflow of a system when increasing the MERV filters? We have some building managers that have gone from MERV 8 to 13 with no capacity to increase the fan speed or overcome static. Carl?
Oh, can you reread that one, Troy? I was actually going to say one thing about Bob's. Bob, we're able to put those in the PTAC units. The devices I'm thinking of are very, very small. So they're easily mounted. Troy, can you repeat that one?
Yeah, well, and hey, listen, at this point, we understand we've run way over here answering questions over our advertised time. We certainly thank you all for hanging in there with us. We see that there's still 82 of you guys and gals on here today, and we certainly appreciate that. So we're just going to continue answering questions at this point, unless we see a huge drop off, because some of these might be your questions. And again, email us or give us a call. We're happy to accommodate offline as well. So John's question, Carl, was, can you review the impact to airflow of a system when increasing the MERV filtration? He said, we have some building managers that have gone from MERV 8 to MERV 13, but with no capacity to increase the fan speed or overcome increased static.
Yeah, I mean, we can certainly come in and do a performance assessment on how that how that upgraded filter is affecting the unit. But essentially, I mean, some units, if you put a higher MERV filter, there's only so much that the unit can actually output in terms of how much air comes in and out and fan speed. So yeah, we could come in and take a look at that and actually see what kind of airflow we have coming out with with that addition of the MERV 13, and then take a look and profile the unit to understand if there is a limitation where it's ID where it's happening exactly.
Yeah, excellent. Now we're actually kind of getting down to the end of the questions, and then Nathan Lindsay has asked the question relative to this maybe MERV question, is what are your thoughts on A-rated filters, quotation mark A, quotation mark rated filters?
The A-rated filters?
Yeah, I'm not quite sure maybe what that means.
I'm just trying to think with an A-rated. I would like to know what size, what dimensions, and where this filters, what type of unit this is being put into for an A-rated. Yeah. Can we follow? Yeah, I'd like to get some more information.
Folks, we have all your questions. They're logged, and if we didn't get to yours today, we'll answer it by email. Again, you can always shoot another email out to me or Carl. Tom Jalot had asked, you mentioned the term bioburden, and what is that again?
Bioburden, essentially, we have particles in the air, and a lot of the particles are biological, right? We have molds, bacteria, viruses, microbiologicals, as we call them. In general, on surfaces like your desk, right, we don't dust for a while. Filtration isn't always, right? We went over MERV 13 versus 8, HEPA, things like that. Particles are very tiny. A lot of the biologicals are very tiny, bacteria, viruses. So they accumulate on surfaces. They can also accumulate in HVAC systems, right? By either getting bypassed through the filter, through openings like we talked about earlier. As they accumulate, a couple different things can happen. And let's just say the space we have, for example, I don't dust my desk and I let it sit for weeks and weeks to months. I get that little bit of dust on there. Less so of an environment where you may have conducive conditions for microbiological growth, but you still have that presence. And when you disturb that, you aerosolize a lot of those particles, and they can in themselves be allergens. Now take that same condition, bring it into an HVAC system. You build up this layer of dust. Now you also give conditions of darkness and moisture. And microbials in specific really like that condition, especially things like mold. What happens is over time, and we see this in a system where that keeps building up, the conditions continue to support the growth. We develop actual microbial growth and bioburden, or all these this growth, this presence and concentration. And it grows, it's in spread, it can aerosolize and come down into the occupied space. So that's kind of how we refer to bioburden. It accumulates, and it not only becomes an air quality concern, but at equal point, as Troy said earlier, this bioburden can then affect performance of a unit by clogging filters, right? By getting on sensors, right? CO2 and temperature relative humidity sensors, and covering that. And then we just take it, from the next perspective into the space too. Bioburden also being, what is our concentration of those microbials? Do we have a very high level, a low level? So that's kind of the way to look at bioburden, if that helps.
Excellent, Carl. Well, listen, I think that's going to about wrap it up. We did actually have a few folks ask us questions on price. As always, that depends on your type of building, your size of building, or equipment. So those are conversations best had offline, when we can actually ask you a few more in-depth questions about your situation, your building and equipment. So, but we do thank you for those, and we certainly will follow up with them. And again, this entire webinar has been recorded. This workshop has been recorded, and so you will all get an email with the link for the replay that you'll be able to share. It'll be up on our public YouTube channel. You can share. And again, you can always reach out and ask for us to give this to your entire group as a personalized or customized webinar, or if you want us to develop some kind of consultative training for your group, we're always open to that conversation. So again, Carl, thanks for joining me today. Everyone who attended, thanks for joining us, and stay tuned for our next online workshop, which will be near the end of February. So those notifications will be going out again. Once again, on behalf of Pure Air Control Services, thank you very much.